morning, everyone.
Good morning, sir.
So here we are assembled here to discuss about the case study that is actually encountered by the many industries. So we are studying the microwave communication in our subject, right? So in microwave communication, there are several factors which influencing to fading of the signals. That is long distance communication, especially. So that thing we are going to discuss. So what are the factors which affects the long distance communication whenever we are using the gigahertz range frequency, right? So that we have to know. We have to discuss some factors. What are the factors which is affecting, and also same time, if you know, if you have some hands of experience in the microwave, we have laboratory classes also, right? So you can give your suggestions to overcome those kind of issues, so that we can give the ideas to the industries. They can implement or deploy their techniques, our techniques, in future communications in their industries, right? So let us discuss about the issues faced by the communication related industries, that is microwave communication. What are the factors which is affecting for the long distance communication? Okay, you can discuss.
So in long range communications of micro processor, it faces many challenges like line of sight. So when coming to line of sight, it requires a long, clear line of sight, so between the transmitter and the receiver, so it can affected by the long buildings and mountains and all, so it blocks the signals, so it is affected in that range. So next is signal attenuation. So in that flow of microwave signals, so in free path the signal may loss, so due to some weather conditions or atmospheric conditions like fog and etc., the cloudy movement, and these are all affected by affected the microwave signal. And next, coming to signal fading, interruption of many signals can affect the signal fading, and it is due to it causes a distortion and fading and interference and all. So by these cases, many signals are affected.
Okay, so as Amrita said, the line of sight is very, very important when the communication is concerned. So the best example for the line of sight is we are using our TV remotes, right? TV remotes to control our television, like changing your channels and some settings like volume and brightness and everything. So when there is some any kind of obstacles, like she said, if you keep some obstacles, any a wall or anything,
Yeah.
right? If it is there in between your television and the remote, even if you change, if you control it, you cannot able to control the television. So because that is actually infrared, that actually requires the line of sight. This is called a line of sight. So which needs receiver and a transmitter to be in the same line. That's a very, very important thing when the communication is concerned, RF and microwave. So this is one of the issues. And as she said, due to the there's a terrain atmospheric conditions like fog and rainy season and some humidity. These are also some because of these things and some water content, the reflections may happen. Then that will leads to interference, and that leads to fading. There is a small scale fading and the large scale fading, right? So as I said, this is a main thing which I observed. That is a main problem whenever the long distance communication is concerned, right? You can share your own views.
Then the major challenge is weather dependencies. While the signal is transmitted in long distance, weather plays a major challenge. For example, due to rain, the signal may be lost information and it reduces its strength. So that in result, this communication reliability reduces. Then interference from various systems. Microwave links suffer from various electromagnetic waves which are produced by the wireless systems, mainly in congested frequency bands. Then security concern. If the microwave is not encrypted properly, then it may posing the risk of data theft.
Yeah. Okay.
And then the biggest problem is line of sight, as Amrita said. Line of sight, high installation cost is required. Suppose we are using the towers at multiple station, means line of sight problem is maintained a long time. So multiple relay stations and multiple towers are needed to maintain the line of sight, and also limited bandwidth frequencies is
Yeah.
Limited
Bandwidth,
bandwidth frequency. To maintain the limited bandwidth frequency,
So if you keep the limited bandwidth, then obviously we can send the signal to only the particular distance. So if you have a wide bandwidth that can able to propagate through long distance in the free space, but it's a trade-off because sometimes we need a very less bandwidth. We have to transfer our signal, and sometimes we need to transfer the signal for long distance. At the time, we cannot able to consider. We should not consider this bandwidth and all. So it is a trade-off. Any one of the things, that's either bandwidth or long distance communication, should be ignored by ourselves with respect to our requirement. If you need only long distance, at the time you cannot. You no need to consider about the bandwidth, right? And sometimes if you need the power loss, mainly focusing on the power, at the time you have to consider the bandwidth. So likewise, we have to go for any kind of our requirement, right? So as you all said, so the maximum the important point, key takeaway from our session of our discussion is the line of sight playing a very vital role, and a signal attenuation is there because of the multi-path propagation. That means, as I said, when the signal is propagated through the space, free space, the signal may be reflected by the buildings, the terrain upside, the water content. So because of that, it will have some multi-path propagation. The signal will be losses, then fading will occur. Then for long distance communication, one more important point is the infrastructure maintenance. For example, if you need to transfer the signal for a long distance with minimum very power, you supposed to have a long distance antennas, right? So, but to building the long distance antenna, that will be very difficult, and the cost wise also it is not a reasonable one. So you can keep some meter distance height, but if you can if you have a very minimum power, but you need to transfer for a long distance mean, at the time you have to build the transmitter, that is a transmitter height, antenna height. It's supposed to be kilometer, 1 kilometer, 2 kilometer. That is practically impossible. And even if you build that kind of a transmitter, right, that will be maintaining by the service engineers will be very, very difficult, right? So these are all the difficulties actually faced by the industry, right? You can tell any ideas. You have any ideas?
So in my view, so in nearby buildings, the tower where there is no area in that near building, we can build the tower, means we can reduce these.
Yeah, okay. So the place where we are keeping the antenna, transmitter, and the receiver should not be affected by some other obstacles. Like it must be somehow free space, right? That's one of the thing, right? And as of my opinion, is we have to see our requirement first. So based on our requirement, we can go for any such kind of a trade-offs. Like if you go for a long distance, we can ignore the bandwidth and the power and everything, right? So this is my opinion. So let us see. We can give our suggestions to the industries so that we can see what kind of improvement which will be takes place in the industry communication. Okay. Thanks for the discussion.
Thank you, sir.